Let's journey with a token block of data as it is converted into a Quaternion data stream. First, we take the block of data and perform preprocessing. This tokenizes the data block into a vector database we call a neural embedding and a symbolic database. A two-dimensional tensor embedding graph looks similar to this. This is how most modern relationships are created. We then encode both the symbolic and the neural information into a Quaternion store. When the data is not sorted, a Quaternion store looks like a 3D tensor database. The difference is instead of just nodes, we have rotations as well. This is why cones are used instead of spheres. The cone represents a direction or spin. It can show the flow of data and help form patterns. Now let's evolve the graph. Let's use a semantic encoding for geometric linguistics, where shapes represent concepts and ideas. This allows each node to hold a vast amount of additional data. When we combine the two, we get a powerful Quaternion geometric symbolic data graph that holds massive potential for data. Not only is it ideal for data compression, it offers instant insight into relationships due to implicit geometry. Complex relationships never before possible to understand now become emergent in the encoding. This is done by creating and establishing complex algorithmic rules we call a codex, instead of positions and shapes representing a fixed ground truth. We can iterate on the same Quaternion node to add data simply by modifying the codex pointer. This creates a multi-layer dynamic system that can adapt to any data structure. It can be as simple or as complex as your data requirements demand. Now let's go back and look into where the compression happens. Remember the unsorted, uncompressed Quaternion data block? Let's bring some order to this chaos. What we will do is utilize geometry to compress this data, with an iterative training loop that will use each semantic vector available and create a single Quaternion symbolic encoding of all cycles. By each semantic vector affecting the central Quaternion, we can create a highly compressed packet that can evolve over time, based on dynamic training parameters. Parallel processing is enabled by different kernels being assigned to different semantic angles of the central Quaternion, allowing as many context analysis vectors to be processed and analyzed as the geometric shape allows. Let's see it in action. We evolve through the token data, forming a chiral structure that can have 3 nodes or as high as your hardware allows. Here I choose 8 to fit inside a GPU's hardware architecture optimally. This is the magic. Each token is compressed into its associated octaves Quaternion. Each Quaternion compression contains the data of that octave plus prior knowledge Quaternions. This compression and free bit temporal structure allows pattern recognition to be outsourced to other hardware while maintaining accuracy, all in a compressed data stream. You need only tap into the pieces of the stream to deduce the data, assuming you have access to the codex information. This makes obfuscation inherent in the system and security embedded by design.